Hello, class. Well, I'm going to be a little annoyed on this one. I apologize in advance, just because I just did it, and then I realized I didn't click on the full screen thing, so you just heard my lovely angelic voice doing this. Anyway, it's going to be probably maybe the last video I'm going to make for all of you. Simplifying rational expressions. We've already seen this before. Let's take a look. First one. 14x to the fifth minus 21x squared. All right, let's see what's happening with this. We've done this before. Got a monomial over a monomial. So I think the best way of going about doing it is something called simplify. 14 over 21. What do they both have in common? 7. How many times 7 go in 14? 2. How many times 7 go in 21? 3. Now let's take a look at the exponents. X to the fifth over x squared. How do we go about doing this? Anyone? Anyone? Well, with division of exponents, all we have to do a little subtraction of those exponents. 5 minus 2. X to the third. Lovely. Done. We've done that before. Not a big deal. Let's take a look at example number 2 right now. Now, I can't just cancel out this 5 with this 25. I can't just and make that a 1 over 5. And I can't cancel out that x squared with that x squared. Well, we did it with this one. Why can't we do it with the other one? Well, this one, everything's being connected by multiplication. This one, we got a trinomial, binomial. You can't just cancel those things out. What we want to do, and it's going to bring up something a little ugly, a little dirty right here, but the idea is with these problems, we need to know how to factor it. Bring everything so hopefully everything is connected by multiplication. Let's take a look at x squared minus 6x plus 5. What can we do with this? Let's see if we could factor it. First rule of factoring, don't talk about it. Second rule of factoring, don't talk about it. Third rule of factoring, GCF. Is there a GCF with this? No? So let's earmuff it up. It looks like it's going to be x minus 5 and x minus 1. So let's take a look at our denominator. X squared minus 25. First rule of factoring, don't talk about it. Second rule of factoring, don't talk about it. Third rule of factoring, GCF, none. So, can't do that. But again, let's do a little earmuff it action. Not earmuff in, but earmuff. And x squared minus 25 looks like a little difference of two squares. So x minus 5, x plus 5. Now we have everything being connected by multiplication. And now what we can do is, x minus 5, what do they both have in common? X minus 5. X minus 5 cancel, x minus 5 cancel, and all we're left with is x minus 1 over x plus 5. Done. We don't need parentheses around this because it's not being multiplied by anything, so we're okay with that. Take a look at number 3, the granddaddy of them all, the Rose Bowl. Anyway, take a look at this. With multiplication, we kind of do everything exactly the same. But let's just take a look at this and treat it as 4 mini problems. Take a look at that first fraction. 4x and the numerator, 4x minus 8. First rule of factoring, don't talk about it. Second rule of factoring, don't talk about it. Third rule of factoring, see if there's a GCF. Let's factor out a 4. X minus 2. Take a look at the denominator. Don't talk about it, don't talk about it. GCF, lovely. Looks like we got a little x plus 3 and x minus 2. Times? Got a little fraction. And first rule of factoring, don't talk. Third rule, looks like they both have a 5 in common. Factor on x minus 3. This one's a little tough. I see they both have it has a GCF, so I'm going to factor out a 10. And when I factor out the 10, I'm left with x squared minus 9. However, you're all smart enough and quick enough to realize that x squared minus 9, that's a difference of 2 squares again. So I'm going to now factor out an x squared minus 9. I'll do it at this step. And you could always rewind and factor x squared minus 9 to x minus 3, x plus 3. Now, bear with me on this one. Look to see where I'm going to cancel. I cancel out this x minus 3 with this x minus 3. Let's see if I could put in some colors. Some colors, ladies and gentlemen. Maybe we cancel out this x minus 3. Am I trying to do colors? It's not working. Let's do maybe this x minus 3. None of this is working for me. This is ridiculous. How is this working? How is it? No, why am I can't put in black. Maybe if I italicize this. No, that did absolutely nothing. Anyway, let's factor out x minus 3 these two x minus 3's cancel. Beautiful. How about these x minus 2's? They cancel. I also cancel out a 5 with a 10. So this becomes a 1. This becomes a 2. But then this 2 could cancel out with this 4. So I'm just left with a 2 on top. Do you follow me? Huh? You with me? Oh, I'm with you. I'm with you. And so let's take a look. The 5 and the 10 became a 1 and a 2. The 4 and the 2 became a 2 and a 1. So the only thing I'm left with on top is a 2. This x minus 2 cancels with that x minus 2. We already took care of the 5. And this x minus 3 cancels with that x minus 3. Take a look at the denominator. I didn't touch the x plus 3, so I got to leave it alone. X plus 3. Oh, another line. Hey now. I already got rid of that x minus 2. I already took care of that x minus 3. And we still have, and that 10 went away. And we still have another x plus 3. So our final answer, ladies and gentlemen, was 2 over x plus 3 times x plus 3. You could also write it, if your heart desires, as, watch, technology at its finest, x plus 3 quantity squared. That was a tough one. Last one, you kind of know what we're going to do. I'm not going to do this one out, but with division, you know this. You keep the first term. Factor it, obviously. Second term, well, change the division into multiplication. And then with the second term, we flip it. Take the reciprocal. And you just factor it, cancel things out. Whatever's common on the top, whatever's common top and bottom, cancel those out. But you could only cancel whatever's on top, bottom. Doesn't matter which fraction's which. I hope this is informative. I hope you have a lovely day. Enjoy. Bye-bye.